Okay, so last speaker of the session, David Trilling, will be telling us about solar system alerts.
Thank you. Thanks everyone for making it this far. I appreciate it. I know I'm standing between you and either lunch, pack session, or waiting in line at TSA. I'm going to talk to you about SNAPS, the Solar System Notification Alert Processing System. I'm David Trilling from Northern Arizona University. These are my collaborators. All the names in red are students who have worked on this project. Okay, what is SNAPS? We've heard a lot about brokers so far this week, which is great. SNAPS is a downstream broker. I'll talk about what that means in a moment. That is dedicated to solar system science. Our goals are the following. We ingest alert data from moving objects, CTF, LSST, and we'll add more to that list. We derive various properties of those moving objects. So for example, colors or light curve properties. We identify individual and population outliers. We serve this data to the community, and we do science related to small bodies. I'm going to talk about each of those just a tiny bit today. I think this is probably well known in this room, brief review of LSST data flow, but I want to highlight the role of solar system objects here, which you may not have thought about the way that I have. That's fine. You probably know that every 30 seconds the shutter closes and away we go. And I know a lot of magic happens in this orange arrow, but let's just say transient detection occurs. And very early on, a question that's asked is, for each transient, are you a known solar system object or not? That's very important for many of the science cases, not just mine and not just yours, but many others as well. And this is binary, yes or no. If no, okay, off you go to brokers, including Antares, and I'll tell you why I mentioned Antares in just a moment. If yes, okay, that's cool. You get reported to the Minor Planet Center, which is the international clearinghouse for measurements of moving objects, all good. You also get reported to the brokers, including Antares. And the reason I've listed Antares here is because I mentioned earlier that we are a downstream broker. By architectural design, we listen to a rebroadcast of an outgoing stream from Antares that sends only the moving objects. So Antares is going to receive all the alerts, and it takes the 10%-ish that are moving objects and sends them onward. And the other 90% Antares stores and does Antares stuff too. So that's why I have this like pass-through kind of arrow here to SNAPS. I just want to point out, you probably all know this, but even if you went on that first path, you're not a known solar system object, you could still be a solar system object. I'm sure you all know that. Either a new discovery, in which case there's no way for you to end on the yes path here, or you could be a known object, but the attribution was not very secure, and so you ended up not with the known solar system object flag, but going this other way. So buyer beware. Okay, this is probably also fairly evident, but what makes SNAPS unique? Well, we're the only broker dealing with solar system objects, dedicated to solar system objects. You all probably know that moving objects present special challenges or opportunities. And I mentioned this already, we're collecting and serving moving object data, deriving moving object properties, and enabling moving object science in a number of ways. Okay, finally about SNAPS, and then I'll move on to about SNAPS design. I think it's important to talk about what SNAPS does and what SNAPS does not. So I mentioned most of these things over here on the does. What does SNAPS not do? Well, we're not discovering new solar system objects. That is a task that is way, way upstream from us. And lots of smart people are working on that. And we're also not handling non-solar system objects. Okay. All right. I'm not going to talk too much about our SNAPS science in this talk because there's not a lot of solar system science in the room, which is totally fine. I'll just point out that we have this series of papers, many of which are related to astronomy and or computer science. We're working, of course, at the intersection. And so we have astronomy papers, computer science papers, and some combination. A couple of things I do want to highlight here. One is this paper that Mike Gowanlock published now 2 years ago, 24, about population outliers. Don't worry about what these three axes are. It doesn't matter. I'm just showing you that we developed this scheme that allows us to detect outliers and inliers in our population studies of asteroids based on feature vectors about asteroid properties. Okay, that's pretty cool. And I think it has broad applicability. I don't know all of the science areas that are in this room, but certainly can be extended beyond asteroid science. The other one I wanted to point out, this is from Erin Clark's forthcoming paper. She's a PhD student working with me. And one of the interesting things that all-sky surveys are really good at finding is these active asteroids. So this is an asteroid that's a point source on most of its orbit, but occasionally is an extended source. And you can see, hopefully you can see there's some tails. Did I get that? There's a tail right here, and there's another, I can't even get this thing to work. Okay, over here. Anyway, there's both these are asteroids that for part of their orbits are seen to have extended emission. Okay, the all-sky surveys are really good because you need a large uniform data set to detect these rare events. Okay, you all know all that stuff. Lots more things coming that I'm not going to focus on right now. I do want to just briefly talk about how to interact with snaps. This is not a live demo because I was afraid to do that, but this is some snapshots from our webpage. So the first thing, which is a little bit hidden here, but I can tell you that right now you have this radio button. You can choose ZTF, you can choose LSST, more radio buttons coming. We're working on the join where you could say, well, show me all the information about my favorite asteroid from the join of ZTF and LSST. Right now they're separate, and that's coming. Okay. We have this handy little tool that does a target complete here. If you type in, start to type your name of your favorite asteroid, 1, 2, 3, 4, 5 is one we frequently look at. And there's actually 3 asteroids in our database that begin with 1, 2, 3, 4, 5. There's also 50 and 51, it turns out. So it's convenient. It's not critical, but it's kind of fun. Of course, we have a login where you can build up some histories, including you can store your favorite queries, your favorite asteroids, and so on. At the moment, we don't have our outgoing alert stream, but it will be populated here on the front page. And that alert stream will identify unusual asteroids. For example, the 2 active asteroids I just showed you, that would appear on our outgoing stream so that anybody, including us, but not limited to us, could say, oh, I want to go observe that guy. Here we go. And yes, we do have a random button, and it's really fun. And it's actually amazing how many times when you press the random button, you find an asteroid that looks really interesting. Okay. Once you've gone through all that query, you end up with some output stuff. This is, of course, ZTF data, and we have date on the bottom and solar system absolute magnitude on the y-axis. And this is just showing our time series photometry for asteroid 1, 2, 3, 4, 5. You also get this product, which is demonstrating a derived property for this asteroid. So asteroids are basically potatoes that are rotating in space, and therefore they have periodic light curve signatures that are brighter and fainter and brighter and fainter. So what this is showing is there's phase, rotational phase on the bottom. I can't work this thing. And magnitude on the y-axis. And the blue line here is our best fit model for this asteroid 1, 2, 3, 4, 5. Okay, so there are many other products you get. I just wanted to show some of those things. We also, of course, have our API. I have no picture to show because it's an API and there's not really a picture to show. But anyway, that's another way you can interact programmatically instead of my favorite asteroid or my 3 favorite asteroids. Show me all the asteroids with this set of properties, or all the asteroids that we observed last night, or anything you can imagine. Okay, a couple more things that I thought might be interesting for this group, especially in light of other broker stuff we've heard about and talked about this week. We store, process, and serve all of our SNAPS data from local machines on our university campus. We don't have a cloud service. The scope is perfectly fine for us to do this, and that brings some areas of convenience for us to do it locally. So that's what we're doing. And we have this kind of scoreboard on our page. This is our LSST. This is as of yesterday afternoon when I grabbed this, the number of LSST alerts that we've ingested and so on. Okay, what else have I got? Okay, let me talk briefly about our timeline. So I'm amazed that I'm going to stand up in public and say this, but we're basically ready to serve our LSST alerts. I would say we're less than 2 weeks out. We have done all that ingest that I said. We have a tiny bit of final plumbing to basically make the LSST look and feel be the same as what we've got for ZTF that we've developed over all these years. And so it's aesthetic stuff. It's not really hard, but it's just to get it kind of right. And at the same time, we're going to put our how-to document on the archive so that people can see what I just told you. Okay, so let's talk about coming attractions. I've convinced you all that stuff. I put that LSST is solved in quotes. We all agree that LSST is solved, and now we can look on. We're starting to talk about, as many others are in this room, about Roman and about Argus. Roman is interesting because we've heard this week that Antares aspires to be ingesting Roman alerts. And I told you that we're a downstream broker that's listening to a rebroadcast from Antares. So that's actually pretty straightforward. Modulo, I don't know exactly what the alert scheme is going to look like and all that stuff, but there's a lot of effort in this room about people working on Roman and rapid alerts. And so I think actually this is, I think it's pretty easy to wrap our hands around or wrap our arms around that and picture what what's going to look like to serve Roman observations of solar system objects. Argus, we also, I think Hank is maybe already gone, but Hank showed this picture earlier this week, and Argus is 20 times LSST scale or some number like that. But it's an interesting solar system challenge because the apertures are small. It's not a very deep survey, and so the number of unique solar system objects is actually pretty small. And so it's also very easy to imagine how we put our arms around ingesting Argus alerts. Yes, it's a lot of data, but it's actually not a lot. There will be there should be no new discoveries of solar system objects in Argus data. And so for us to ingest it and deal with it, I think is going to be straightforward. Don't quote me. Okay. There's novel challenges. You all know this, novel challenges in scale and scope with both of those. But and you know this in your science, I'm telling you on my side as well, that there's interesting science opportunities there by combining wavelengths and timescales in particular in the solar system. The Argus timescale is completely unsampled in solar system science. And so that's pretty neat to combine that with other data sets we've talked about. Okay, here's the end. SNAPS is the only dedicated solar system broker doing science with your trash since 2018. We serve value-added moving object data. We detect individual population outliers, couple weeks, ... And finally, we are really a mature broker because I actually have stickers with me. So if you want a sticker, come and get it at the end. Thank you very much.
All right. Questions for David? Possibly.
I just want to make sure that I totally understand the downstream broker aspect of this. So if I get something from Antares that's not through Snap, it will not have an SS obj ID.
That is an Antares question. My understanding is that there's a beam splitter, Antares, right? All the solar system objects go that way and you'll never see them. And all the non-solar system objects go that way and I'll never see them.
Okay, that's very cool.
It is
Not
very
know.
cool.
I
Yeah.
will confirm.
Additional questions? Manzi.
Thank you, David. The question I had is, you had something like 466,000 and only 456 are real solar system objects. What happened to the 10,000?
Yeah, the fidelity on that measurement is not great because it's estimated. There's a couple things that I buried in the weeds there, but I have to look at my email to give you the proper answer. But that number was meant to represent the total number of observations and the total number of unique objects. So objects could be observed multiple times, and that's why the numbers would not necessarily equal.
I see.
There's-
It's not
there's-
garbage. It's,
It's not garbage. No. We're only listening to objects that are flagged by the surveys as known solar system object, and it is object number blah. So all the identification stuff is upstream from us, and so our sample is quite pure. Should be 100% purity.
And can I ask another question? The random button, is that truly just random, or is
Yeah.
that actually anomalous or something particularly interesting.
No, it's
about that,
random.
but-
It picks a random object, a random solar system object from our database and will display it for you. And if you like browsing solar system light curves, and of course you do, it's the number of times we've hit the random button and be like, wow, that's really weird. I've never seen a light curve like that before. It's happens all the time. It's really, really informative. We did it for fun, but it has turned out to be a useful investigation tool in a sense.
Okay, Dave, one last question.
It's more of a, maybe a strange question. Dave, what is a downstream broker?
So that was defined by the LSC project in the days of yore. And the idea was that we would not connect directly to the LSST outgoing stream because there was a limited bandwidth or a limited number of ports that people could connect to. And so we listened to Antares and Antares listens to LSST. Whether that practical limitation is required anymore, Eric probably could say more about it, but it doesn't matter because that's the architecture that we've designed. And in fact, we have been able to listen directly to the whole stream from ZTF and LSST, and we just discard everything that's not solar system object. So that's by design, we're only listening to the 10% that are identified solar system.
Okay, with that, let's thank David one more time.